I hope you are doing good. In this tutorial, we will learn what is graph attention and why we need, how the problem are solved mathematically in a very easy way. And I will explain each step along the way. Whenever you need to understand maths, I would suggest pause the video, try to understand the motive behind the steps, and then move on. I would like to divide this into two parts. First part will discuss data preparation and second part will discuss attention score calculation and message passing. So let's get started. And I have this very simple data. Let's assume we have this relation stored in our graph database like Neo4j. And I have assigned here some index against each node, and that you will know why a bit later. So each node has some feature. For example, as you can see here, phone has a feature called screen size. It is also mobile related. Charger is accessories, and it is battery related. And laptop is also has a screen size. This is one of the feature, and so on and so forth. So in this table, I tried to put the relation from the previous graph. As you already noticed, it shows which node has which feature. So phone has screen size, it is not accessories related, also not battery related, but it is mobile related. Similarly, a laptop has a screen size, it also not, it's mobile related, but it's very less feature, and that we'll see later how the graph attention scores these things. That is the beauty of graph attention. And then also charger is not, doesn't have screen size, it is exercise related, and so on and so forth. So what is the problem with this data? The database relation tells us store data, but it cannot predict which is the best for a given use case. So for a mental model, imagine that graph database as Google Maps, but it is the best way to reach to our destination considering different features or mode of transport that graph attention layer, or in short GAT, can tell. So in our example, we see a phone is a mobile device which has screen, but it does not tell us it is related to battery or accessories. So now wait a minute, is it not really possible to query 2-hop or multi-hop to find it out how source node is connected to target node? Yes, of course, but that is rule based, right? Someone always have to maintain the rule, weight, and there is no learning based prediction at all. And in some cases where 100% accuracy is required, then rule based always first class citizen. So that is the difference between rule based and prediction based, right? Whereas GAT-based prediction wins when you need to find it out which neighbor is more important than other based on truth facts in graph database. So this is really important for you to understand that our source of truth is graph database, which is always have the facts, truth facts, and based on that we are learning our predictions. So GAT shines when it combines with graph database. So then what is our goal? Our goal is to learn how close each objects are to each other using their feature, and which connection between objects are actually matters. So what we want at the end, that GAT tells us that feature of each node should be updated based on its neighbor information. In other words, how much phone should listen to battery versus charger versus case to make a prediction and updates its own understanding plus neighbor information. So phone listen to x1 percentage of case and battery y1 percentage and so on. And this is the same for all other nodes as well. So from the next slide onward, we will calculate each step how math actually works behind the scene. So we will learn that how this percentage is calculated. Okay, so let's move on. So first we need to convert previous feature data into tensors, and I'm going to use PyTorch for this tutorial. So if you're not familiar with PyTorch, just have a quick in some crash course and you will be good to go. Okay, so first we need to create a adjacency matrix. And why? Because we need to find it out the age of each node, right? Meaning how they are connected. So here phone has direct edge with charger and battery and cable as well. So if we continue to find the edge, then the matrix looks like this. So let's not forget each node has its own feature. So in other words, self loop. So let's fill it in. And if you remember why it is important, because GET framework again tells that it has its own feature plus it needs to understand its neighbor feature. So this is the final adjacency matrix look like, and again we need to convert this into a tensor, right? So this is how things works. Move on to the next slide. First we need to find it out how do I represent each node feature. Okay, so it's important to pay attention here. I'm talking about each node feature. Okay, so we need a learned vector. Okay, and why? Because we do not have initial representation of node feature based on which we can start learning. If we go back, if it sounds a little bit confusing, then if you go back to previous slide, and there you will see that we have only node versus feature relation, but no information about feature itself. So we initialize learn vector called W. For this example, I used 4 as an input feature and 2 as output feature. But in practice, these two numbers will be more. Even output features can be more than input feature and so on. This is a very minimal code I added here. And this is what we get after we execute this one. I would like to plot the vector so that I can visualize how vectors are defined. So it just gives some mental model how vectors moves in the space. If you remember previously, we have got nodes feature vector and we have now initial learned feature vector, right? So initially we have got nodes feature vector and now we have got learned feature vector, which is the initial learned feature vector. So what we want next is learned representation of nodes feature. Why? Because with raw data there is no non-linearity, and model cannot learn when the data is linear. And how can we do that? The answer is matrix multiplication. Okay, here you notice how matrix multiplication is calculated. So if you remember, this is the tensor data we have. So if we do the calculation like this, okay, then we receive this called WH. So the calculation is again screen size, which we have got learn vector, and then the whole calculation is given here in this presentation. So I would suggest that you pause the video here and do the calculation, and also do a recap what we have done so far. So in the next part, we will learn a very interesting topic, how attention scores is calculated. So see you in the next video.